No, what that means, what it's doing is I do a screencast, right? So this is showing me what I'm showing in the screen. Therefore, the screen is showing what's in the screen, showing what's in the screen, and showing what's in the screen. And that's why you see the infinity there. So you're always seeing the screen of the screen showing the screen in the screen. So, okay, we're good. So we left off yesterday on this slide, I believe, and we were talking about some of the properties of the exponential functions. We did talk about domain. It's going to be from negative infinity to positive infinity. It always will be. Your range might change depending on whether you shifted this function up or down. We did talk about tracking the point 0, 1 and not the point 0, 0. These functions will always cross the point 0, 1. That's like your starting point, okay? So if you started off with, 5 things or whatever, then even if you take 5 to the 0 power, what's anything to the 0 power? 1, and therefore they should always cross 0 to 0, comma 1. Did I talk about how you get the red function, the negative function? Okay, you want b to be a decimal or, good, so I did talk about it. So you're going to make x negative, forcing you to flip the base. I'll say that one more time. Corbin, you weren't here yesterday, were you? So here's what I mean. So we have exponential growth, and exponential growth kind of looks like this, right? And there's our point 0, comma 1. That's only true if in my function y equals b to the x, if b is bigger than 0. Sorry, not bigger than 0, what am I talking about? It's got to be bigger than, how much? 1. Bigger. Cannot be equal to 1, because once I put 1 in there, what's 1 to any power? 1. And what you're going to get is going to be some flat line that just does this, flop. And that's not what we're after, okay? So make sure that it's greater than 1, never equal to 1. Now, in order to get exponential decay, which is going to be the line that goes this way, kind of like that, I want b, this is growth. Now we're talking about decay. I'm going to want b to be less than 1, but bigger than 0. Not equal to either one of those. Because remember, what did we say what happens when we make b 1? We're going to get flat line at 1. And if we make b equal to 0, we're going to get flat line at 0. Because 0 to any power is still just 0, right? So what we're really looking for is some fraction in here for b to be a fraction. So if I said, I'll use another color, y equals 1/3 to the x, then that's going to give me that exponential decay. Because I'm always taking a third of the last part, a third of the last part, a third of the last part. Therefore, it's going to get smaller, 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 faster. The other scenario, or an equivalent equation, I should say, would be y equals 3 to the negative x. Because can I have a negative exponent? No. And the way that I fix that is by flipping the base, correct? So if I flip the base, don't I have an equivalent function there? That exponent becomes positive, but I have to flip the base, therefore making it 1/3. So those are the two ways that I can get exponential decay versus the growth. We did get past this. We talked about this function, right? We did talk about this function? Transformations? Okay, so as a review real quick, let me go back to here. So laptops? You guys are taking notes on that? Thank you. So as a refresher to everybody and as a new to everyone else, this is kind of our basic function for exponential growth. B to the x, b is some base value. But we talked about how, what did we talk about yesterday? We talked, yeah. Do you remember how when we were working with parabolas, there's a couple numbers that would change how slopey it was? So it would change this business? And then there was an A value, huh? And then if A was negative, it would flip it, kind of thing. No, thank you. If we had an H value, then it would change it horizontally, like this way or that way, right? And if it was a if it was a K value, then we could shift it up or down. So same ideas, except they're not going to be in your typical place. Well, two of them will be in the typical place. We would have. Let me rewrite that real quick. So as just a reminder, we have y equals a x minus squared, a minus h, oh, wrong spot, h, and then we have plus k, right? And that's not an r. So a would change how much slope that thing has, the h would shift it horizontally, the k would shift it up or down, correct? And we kind of played with some of those things yesterday. Do you guys remember how we would take a parabola and change it from being smiling to be frowning? Negative what? A. Negative A. With a parabola, we also said, because that's a reflection on x, correct? And remember I said we could do a reflection on y, but you really couldn't see it? Yeah. How would we do that anyway? Like, let's say it doesn't matter, but we still do it. We want to flip it on y. How would we do that? We would make x negative, wouldn't we? So that's kind of interesting. Let me go back to our other slide. So let me go back to our other slide. Here. Do you see how this is my y equals b to the x? How can I make it flip so that it's negative? What do we say you do? You make x negative. And that gives you that decay. So all these rules, once you know the rules and what each thing does, it holds true for all functions. And all we're really doing is taking it from one and we're applying it to another. Okay, so nothing changes. So here's what I was saying about that. New slide. So if I had a function that read y equals b to the x, I could change how fast or how slow it decays. And then I know I don't have a camera anymore, so you can't see this on the recording. I simply have to change the value of a. Yeah. So let me get this right. It would go like this, right? So how slow it decays, or no, grows. How slow it grows or how fast it grows would be an a value kind of thing. Make sense? Now, if I want it to become decay, which would be a reflection on the y, I would have to make x negative. So I'll just kind of make a note here if I needed to. Let's say I wanted to shift that for some reason horizontally. What was the value before? It was an h. And where did it usually show up? It showed up with x, didn't it? It was x minus h. Same business here. Let me get rid of this negative. So we have the same business going on here. So it would be, I meant to drop it. I meant to drop it. Things work better when you drop them. That's why things are sold in vending machines and they kind of make them fall.
It works on guns as well, right?
Yeah, soda pop, right? Dogs. And then if I wanted to shift something up or down, the item responsible for that was the K value. The K value will still be out here. So we still have all of those same ideas, all of those same components that we had before, and how it affected our function still affects all of our functions the same way, whether it was absolute value, whether it's quadratic, a cubic, whether it's an exponential growth or decay. Is that a question?
Yeah, of course.
Ladies first?
Oh, yeah.
Go ahead.
Oh, sorry. Well, the H, like, is it the same? It's not the same as when you do like this quadratic, right? Like, it's not a zero. You know what I'm saying? Like, you know
No, it's not. And we had that. We talked about yesterday. How do I explain this? Before, we used to track the points 0, 0, correct? Almost always. Whether it was a parabola, if it was a cubic function, we would track the point 0, 0, because that's kind of it was kind of the center of it, right? Or the important part that never really changed, remained consistent. Even if we did absolute value, that would be the same thing. And if we did, quartics or cubics of any type, odd ones, they behave in the same fashion. Now we have something that's a little different. Ours doesn't cross the point 0, 0. It always crosses the point 0, comma 1. So now, why? So let's go back to this function real quick. Y equals b to the x. Let's make x 0. Okay? So now I have y equals b to the 0 power. Now b can be any number that you want to be. I don't care if it's 1, 2, 3, 5 billion. Okay? What is your number to the 0 power? When? Sometimes? All the time. And that's why we will always follow the point 0, comma 1 instead of 0, comma 0. Because that's the point that we know will always hold true for any exponential function. So now when we go back and we think about that kind of being the idea of the 0 or even the vertex, kind of like we used to before, not in this scenario. Okay, in this scenario, it would be, because we used to follow, what was it, h comma k? Right? It's no longer going to be h comma k. Now it's going to be, what's it going to be now, yo? H comma k plus 1. Because remember that k value is the up and down, correct? Before it was 0, 0. But now it's at a 1, it's 1 higher than it usually is. So therefore h comma k plus 1. Did you have a different question, Corbin?
Yeah.
Hold on, I can't hear Corbin's question. Can you show some professional courtesy here?
On the exponential decay, so whenever the x value is negative, so would the negative be outside of the parentheses? Like you have a h value too, so those parentheses.
Even if it was outside, you'd have to distribute it, wouldn't you?
Yeah, that's what I'm saying.
So it doesn't matter if it's going to be on the outside or if it's going to be on the inside.
Distribute the negative to the h2.
Yes, you would have to. So that would be the only difference. So the question is, if I've got exponential decay, I know it looks like this, correct? But if I did have an h value, I could be looking at something like negative x minus h. And that would not be the same thing as having this. Because this is the difference between moving left and moving to the right. Okay? Notice they're both negative h. Here, I don't have anything to distribute. So I would be moving to the right, while in this case I would be moving to the left kind of thing. Okay? So be careful with those things. What's up? Huh? Never mind? That's the easiest one. I can never mind. Fantastico. All right, so we're looking at this function. Take a look at what we have here. Wait, where's the rest of mine? Oh, I'm just going to use my calculator. Whoa, welcome to infinity. I was going to ask you yesterday, Miss Beth, did you cut the hair?
Yeah.
Okay. We were talking to somebody like, it looks shorter, it was Sharice. Didn't I ask you if she cut her hair?
Yeah. I told her about it.
I was like, did she cut her? Has always been that short, and I'm just being a dude and don't notice. Okay, here we go. Y equals, let's clear this real quick. Waterfalls! Right now, the expectation is that you guys are listening to what I'm saying, because like I feel like I could have just gone off on a tangent and start talking about Michael Jackson and his love child with bubbles, and you know how, yeah, and y'all wouldn't even know. The expectation when I'm doing this is you're listening, ready to ask some questions, because something that I say is something that you might miss, and then when you guys are testing, I'm like, we never got to that. Well, I could have said it, but we were too busy talking about getting our hair. I did notice though. I just want to point that out. Let's go back to here. Let me delete that. So I want an exponent of x. Can everybody do an exponent of x? Okay. Just make sure you use this caret button here. Now, here's that function. Let me graph that real quick. That way it does. Oh, I forgot to do something. What did I forget to do? What? My window. Yeah, because it looks like it's asymptotic, but it's not. I'm going to go window. Sorry. Just kidding. Zoom. And I'm going to go to standard. The difference between window and zoom is that in window you pick the values. In zoom it'll give you some pre-chosen things. Okay, so that's what it looks like. Actually, I'm gonna do one better. I'm gonna go square. That way it looks more accurate. So there's the asymptotic. So you see how we're crossing 0, 1. Thank you. Let's take a look at this next function. We've got 3 to the x minus 1. So before I hit enter on this, I want you to turn to your neighbor, and I want you to talk about what's going to happen to this new picture. Talk about what you think is going to happen. Don't talk so much. You're going to get tongue tied right. How many? Why?
I start reading around 7 and 8, and then I'll be on time, you know? Don't touch me there. Don't touch me there. I'm gonna touch you there.
On your desk, there should be a tablet. A small whiteboard. It's got 2 sides, yo. Sketch me your new graph, please. Oh, damn, Daniel. Damn. I want to see if you guys got your own.
Philip doesn't have one. Me.
Who has the extra whiteboard? There you go. They should all have one.
Bro, I don't think it's very Oh my god.
He's going to tell you how much it's going to
Okay, so here's the original one. That's changed. Yeah, Philip. Like, you guys want me to do it?
Now, here's what I would suggest. You have
Yeah,
one.
but
Sorry, what is our answer?
You still have to cross the 0, 1.
guess what I'm making right now?
I don't know.
God, I said,
If I knew, I definitely would. Because I could have. Ever waste your time in this? Waste some time.
Bless you. So violent.
Oh, this is the new one. Never mind.
And then yours is not cross through 0.
My name's not Susan.
Well, you're not nameless.
It used to be in another life. But it was more like a Suzette. I don't know. That was dumb. I'm sorry.
Everyone in my family, I can guarantee there are at least 10 people in my family named Susan. Susan or I just, yeah.
Okay, saw some great graphs out there. The first thing that I checked for everybody was simply that your whole function was shifted. Which direction? To the right. How many units? One. Pretty simple, y'all. There it is. Now, some of you guys that said that's good, not exactly correct. Because I think everybody saw that, you know what? If I did have 0, 1, then that just goes over here to 1, comma 1, right? But you're going to need more points than that. So let's talk about this real quick here. And what I like to do is I'm just going to kick it, kick it primitive style. Let's stop and think about this. If x was 0, what would the value of y be? 1/3. So here I'm going to go about 1/3 of the distance. You get the point. If x was 2, what would the y value be? 3. If x is 2, 2 minus 1 is 1, and 3 to the first is just 3, right? So if this was 2, I would go here. If I've got 3, it is 3. I would get 9, right? So now I got a lot of good points that's going to help me out here. Over here, I don't really need to get you crazy because what's going to happen?
It's gonna flatten.
It just kind of flattens out. It becomes asymptotic. But can everyone see that that will simply shift over to the right? 1 unit? Simple. Simple stuff. Oh, not the right one. Oh, yeah, it is. Oh!
Everyone did great.
No! I have a program on my computer.
Oh, I want to go back. I just saw you and I remembered. When we go to here, some people have questions about what is A and what is B in this case, right? It's going to be kind of hard to distinguish between what A is here and what B is here. I'm going to assume that this is simply going to be the B value because it's going to be a 3 where A has a value of 1. Okay? Or you can make the assumption the other direction, that this is simply going to be, actually it wouldn't be 1 to the x, because then 1 times itself over and over and over would simply be 1, wouldn't it? So I'm going to make the assumption that there's no A value here. It's only going to be a 3 to the x kind of thing, with A being equal to 1, where it's not affecting anything else. Okay? Natural base E. You guys remember logarithms? Yeah. And we use that then sometimes. So for starters, you just want to make a note. E in math is going to be a number, and it's approximately 2.71. 2.71. Okay. Yeah, we're just finishing it up in yesterday. Okay.
Wait, what?
Can someone Google for me real quick the compound interest formula? The compound interest formula? I believe it's got like 1 plus 1 over n to the nt. You found it? Settle down, settle down, settle down, settle down, settle down. Waterfalls! Go ahead.
It's P parentheses 1 plus R over N.
R over n
Yeah.
to the
NT.
nt. Okay, so even though this is R, so this is the compound interest formula. And does everyone understand the compound interest idea? Okay, so let's talk about that. So I go to a bank, I've got $100. And they say, you know what, if you leave your $100 in my bank, we're gonna give you 10% interest, okay? So I go in January, day one, I drop my $100 in there, and then if I don't touch it for a whole year, I'm gonna get back 100 and, sorry, I should say 100 and, I'm gonna get $110 back, because they've given me 10% on what I put in. Does that make sense? Simple idea, correct? So I could do that, and that's actually a simple interest formula. It's a I equals PRT kind of thing. So if I leave it in there for a year, I can get what I get out. Now, things are not that simple because banks are about money, correct? Especially credit cards are about taking your money. So what they wanted to do was like, you know what if I didn't want to give it to you every year? What if I wanted to be greedy and I wanted to give you, I wanted to charge you interest every month? Every month, right? I would do, so that means that at the end of 1 month, so now we're not talking about how much money I put in the bank, it's how much money I kind of owe you. So what I would do is at the end of a month, I see how much money you have in there, and I'm going to charge you my interest fee on that. Does that make sense? And then once I get to the next month, I'm going to see how much money you owe me now. That includes what the interest, because now it's money owed, and then I'm going to charge you interest on that. So let's say, for example, let's keep it simple. Let's say I did spend $100, and they're charging me a rate of, let's say 12%. So I'm going to need a calculator for this. So this is, thank you. This is January. So that means that February comes in, and now instead of owing them $100, I'm going to owe them $112, right? Because I didn't make a payment. Is everyone okay with that? I didn't make a payment. They're going to charge me 12% interest every month. So now I owe them $112, correct? Then, here comes, what's next? February, January, February, March. So now, am I going to pay another $12 on top of that? No. No, because now I owe them $112. They're going to charge me 12% of 112. So now I got to do 100. Can somebody find 12%? Can somebody find me 12% of 100 real quick? Sorry, of 112? I got 13.44. Can someone confirm that for me? Okay. Now, do I really owe them $13.44 at the end of that month? No. I owe them, say that one more time. I have to add that to the previous. So that's what explains this part of it. This represents the original 100 that I owe you from the last, plus whatever interest I've accrued now. So now, so instead of doing 1 and then that percentage that's at 13.44, I'm going to add the original 100 to that based off of this. So this is going to give me, I'm going to go ahead and add 13.44. So now I owe them, dang it, I missed this. This is wrong. What was it, 13.44? Times 1 times. Do you even calculator, bro? So now I owe them $125.44. What happens when I get to April? I'm going to multiply 125.44 by how much? Wouldn't it be easier, instead of me sitting there and adding all that stuff, to say, you know what? I owe you 125.44. Let's multiply by all of it, the 100% and the 12%. So this would give me the 0.12, which would be the rate, and I would have a 1.12, and that simply gives me how much I owe altogether, correct? So I have 125.44 times 1.12, and now I owe them $140.49. We'll round it off.
Wait, so what is the R on the end?
Well, that's what, so hold on, do we understand what I'm doing first? Because what I'm doing right now is that simple interest idea, N equals PRT. Instead of me sitting there and doing this over and over and over and over, like for example, if I said, hey, what am I going to owe you in October? What am I going to owe you in October? Can you imagine sitting there and doing that over and over for that many months? No. So this formula was created that they'll take this original amount and you throw in the time and the number of times that you're going to compound. Oh, I'm doing it every 12 months, and I might be doing it for a year or something. That's what these numbers would be in there, and it would actually do all the math for you. Does that make sense?
So what is
So I don't have to sit there and do every month after every month after every month. So what they
Squiggly R later, right?
squiggly R?
Yeah, what's above the N?
It is an R.
It's an R.
It is an
wasn't
R.
one
It
before.
was a 1. It was a 1.
And what's that stand for? That's rate.
It's rate.
What is the N?
So that
But
would
let
be
me put that aside for now. Let me put that aside for now. I want to write a very different version of this real quick. Because this is where it came from. It came from this idea of 1 plus 1 over n to the n. So what this is doing is it's a kind of a compounding type thing. Okay? Now here's the idea. Let's say that I did have this, and then I were to pick, do me a favor real quick. Can you guys calculate that if n is 1? Find that for me real quick. You should get something for simple.
We should get one.
We're just going to explore this for just because we can.
Actually, probably is.
What are we going to get? We're going to get 2? Correct? So we're going to get 2. What if n was 2? What if n was 2?
So it'd be 1 half plus 1. No, 1. So it's 3 halves.
You guys want to? You guys know what I'm going to have you do? I want to make n bigger and bigger and bigger and bigger and bigger.
Which
Until it
realizes
realizes
it's
2.25.
Say that one more time.
2.25.
Can someone confirm that?
I just.
I got you.
2.25? Okay. What if n was 3?
3?
Yeah.
Wait, 2.50.
No, someone please do the work.
2.37037.
2.37 is good. Okay. Thank you. So I just want to pause there for a minute because we're going to start making n bigger, bigger, bigger. And I want to explain to you what's happening. If they charge me interest once a year, is that going to be more or less than if they charge me interest every month?
More or less. Or less.
Oh, what if they did it twice a year? Would it be more or less? Would I be paying more interest or less interest? If they charge me twice a year instead of once a year?
You'd be spending
Oh.
I would be spending more, right? Now, would it be more twice a year? Let me write this down the board so we can. So, if n was 1, I would be paying. Let's say on my $100. Someone give me a percent. Just make it up.
34.
Of course, someone would say that. 12%. I'm gonna pay $12, right? What if it was twice? That means every 6 months. How much would I pay interest on that?
Oh my god, you took my percentage.
Awesome. I should have. I didn't. Well, we found that, didn't we? What was it?
Yeah.
Oh, I threw it away. Why did I throw it away?
Oh, it's 2.25.
Did anybody write them down?
It's 2.25.
It was. No, it was like.
Oh, I'm lying. Oh, it's 4.
Lily's 12.
What are we looking at?
If they did it every 6 months, so we have 100. At the end of 6 months, I would have 112, right? But at the end of 12 months, I would have 12% on this 112.
125.
Is it 125?
Yeah, 125.
Okay, so I'm paying more, correct? Now, what if instead of doing it every 6 months, I said this is called semi-annually, okay? Annual, and I probably didn't spell it right. Now, what if I said quarterly? What is quarterly? 4 times, right? It would be every 3 months. So if I said, what if it's quarterly? Am I going to pay more interest or less interest? More? Can you guys find that real quick? So you're going to charge me, so I'm going to have, let's see here. I'm going to start with 100. At the first quarter, I'm going to be 112. At the second quarter, I'm going to be at 125. At the third quarter, so what's 125 times 1.12? 125 times 1.12. It's 140?
I got 140.
It's approximately 140. Now, at the end of my fourth quarter, so this is what I'm talking about. So at the fourth quarter, what's 140 times 1.12?
156.8.
156.8? So, what happened to the amount of interest that I'm paying? It's going up. So, here's the idea behind this real quick. Let me erase this. If, let's say I didn't go from quarters, now I went to monthly. Am I going to pay more?
Yes.
I'm going to pay more, right? What if I went to, what did I say here, monthly? So this would be 12 times, right? Monthly? What if I said, what if I said weekly? Would I be paying more interest?
Yes.
A lot more?
Yes.
What if I said daily?
You're broke.
Would I be paying more interest?
You're gonna have to show you.
What if I said hourly? Would it
Oh,
be?
God.
Could you imagine that?
Secondly,
What if I said every
millisecond.
Every 30 minutes.
Munoz? Okay. Nick Duran, you're outie. So, what did we say daily? We said hourly. We said every minute, right? Can you imagine how much interest you're gonna pay if they were charging you every minute? Question. Now, here's the kicker. What if I charged you interest continuously? Like one after the other, after the other, after the other, the other. How much more interest would I be paying?
Infinite.
Would it be?
No,
That's the idea behind E. That is the idea behind E. Okay? Thank you. Hold on, slow down. I don't want people confused. Put those tablets under. It's not rec time.
Sorry, I have ADD. You can't give me a marker and then this and it's
No, that's my fault. That's why I'm saying put those under. It shouldn't put on top of it. I'm trying stuff out. I'm experimenting. So here's what we're saying. Hey, Lauren. So remember when we did n times 1, we only ended up paying what? $112 at the end, right? It was $112 what we paid. And then we said, what if we did it twice? Now I paid $25 more in interest, didn't I? And then if I did it 4 times a year, I ended up paying $56.80 more in interest. And then if we did it 12 times, it would probably be closer to $200. And then maybe if I did it weekly, because that would be what, 30, how many weeks? 52, holy crap. I would have 54 times I would do that. And if I did it daily, 365. So can you see how that interest is going to increase? Which is kind of mind-blowing, isn't it? Like, wow, people would do that? Yeah, they could if they would if they could. But then the question came up, what if we were to compound continuously, like nonstop? Okay? What was the formula that we used for that? It was 1 plus 1 over n to the n power, right? So, that's where that formula came from. But this is what the mathematicians came up with that would model that situation, basically. So, as n gets bigger, my interest gets bigger, doesn't it? Yeah. And then I think, Blue, you said, what if I just said continuously? You said, man, there'd be no limit to how much I'm paying, right? Would it really be a big difference? Would it be a big, big difference from the last one? Well, that's what E is. And they found this number. They found this. If this went to infinity, and this went to infinity, you know how much interest you would be paying? What that value would be? It's E. It would be 2.71. Let's try that out. You guys have a calculator in front of you? Here's what I'm going to do. I'm going to let my calculator model for me.
Yeah, God, how do you get that? How do you get 2.7?
So here's what we're going to do. Parenthesis 1 plus the fraction 1 over, I can't do n, but I'm going to do x. That's okay, right? And this is all going to be to the x power. So here is the graph of that bad boy.
Just starts out around.
Did I write that correctly? I feel like I didn't even write it correctly. Let's take a look at the table. Maybe I did. So here's my. Okay, so cool. We have error. So let's see here. This is going to get bigger. I want to change my table where it starts. I'm going to go on my table. Do you guys want to start at 100 maybe?
Sure.
Because remember, we're getting bigger, correct? So let's push enter. And right now, what we're just exploring, correct? You guys okay with that? You guys okay with exploring? Cool beans. So here's my table. Oh, come back. So check it out. Look at these numbers. This is at 100. Where are we at? 2.7048, 2.7049, 2.70. And is this really changing much? It's not, is it? Let's go a lot higher here real quick. I'm going to go back to my table set. You want to go to 1,000? I heard 1,000. Let's start our table at 1,000. Let me push enter here. And then if I go over to my table again. Oh, look at that. We're at 2.7169. Oh, whoa, look at that. Does that even change it? Let's go. That was a good call. Let's go to
1 million. 1 trillion.
how about that?
Oh, yeah.
10 million.
You can't say that number.
Second table.
No, that's a billion.
Where are we at?
Oh my goodness.
So here's the point, Blue, is that there's some point. Are you trying to do that too? We're gonna get to a certain point where we're compounding interest, where doing it more often doesn't even matter anymore. Like you're not gonna get a big difference. Are we getting differences here? This isn't even changing at all, is it? Isn't that pretty cool?
It's probably
So as n goes to infinity, as this thing gets bigger, we're approaching some number called 2.7183, blah 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 blah. We've called that number E. Questions? Questions? Hey, who would pass? You guys need a minute to wrap your mind around that? I need therapy? What? Okay, some things you need to know. That number that we found, that is approximately 2.718283 in the other calculator, is an irrational number. It will never, ever stop. And we call it the natural base. This function here is called the natural exponential function. And that should make sense, right? If e is a natural base and we put it to an exponent, then it's the natural exponential function. See or no? See. On. Okay, for the sake of time, I'm going to jump a couple slides to here. Can I get rid of this? Are you guys good? I'm going to jump to this slide here, because here are our compounding formulas. Do you recognize that 1 plus 1 over n to the n? That's where it came from. This is where this was developed based on that model. And then down here we've got the continuous. How do I know it's continuous? We've taken that 1 plus 1 over n to the nt, and we've gone to infinity, therefore creating e in our function. So pe to the rt would be a continuous compounding.
Wait, hold on.
How much time do we have left? We have 5 minutes? 5? Okay, so here's what I want you to do. I've invested $500. I want you to tell me if there's a difference, or how much of a difference I should say. Let's see if this is surprising or not. Between compounding every 12 months versus getting compounded continuously at a rate of 0.15, which is 50%, for 2 years. Okay? Go ahead and do that. Find me what the difference between doing my compounding versus a continuous, where my rate is a 0.15 and I do it for 2 years.
Oh, what's P?
It's my principal. I start my deposit. It's my $500.
$500. So you're getting compounded interest every 12 months, right?
Yes.
Is it to the power of nt?
What?
To the power of nt?
N times T. That's the formula. Correct.
I have the the number for the continuous compounding. That's p e to the power of r times t.
It just depends on something.
T is 2 years. T should always be time in years. You should always be time in years. Hey guys, great question. E is going to be on the far left. Okay, good. Whenever you do these formulas, T should always be time in years. So even if you're doing, is it, but by how much?
Like, by 1. Wait, no, not even that. It's like by point something. Let's see.
Let's go ahead and let everybody finish up first. Go ahead. Yes, you may.
Wait, never mind. We ain't even got it.
Nope.
Oh, yeah. You have a Casio. No, you have a Casio. Yeah, that's,
Alright, I got my answers. It's like
I think you plugged in 2 hours for that.
Okay. Waterfalls. So let me get your attention up here. So, do you remember how we said continuous is over and over and over and over, doesn't ever stop? And the question comes down to, hey, which one of these is more lucrative? Which one's going to make me more money? Doing it every month or doing it continuously? Well, how much more money am I going to get if I do it continuously? $1. I'm going to get $1 more. Now, that should answer to you why we only charge every month on interest or any of that kind of stuff. Just thought that was kind of cool. We're coming out of. You should have homework tonight.